a little bit about storage, and then we will get into details of offline itself. For quite a beginning of the part, I'll talk more about storing data, and then later on we'll talk about the offlining part itself and a few things we need to keep in mind. First of all, why should we worry about offline applications? Let's say for a minute that, well, one of the nice things about our modern day technology is everybody walks around with a huge amount of computing power with them. Today we have more power on our hands with these devices than huge computers that filled in rooms a few decades ago. Now obviously businesses want to put this to really good use. I do quite a number of things on my mobile device, and I have my clients who do a lot of things on their mobile devices, and a lot of times they may use the application and they have a choice of building native applications. Now when they build native application, of course, the application runs on that specific platform or type of device. But what if people want to use different devices? Some companies have standardized on devices their employees would use. And for those people, native applications definitely are solution. And I do favor native applications. I like developing native applications. However, there are times when we don't have a control over either the devices people would use, or you do want to give them the flexibility to use different types of devices. So if they want to use 2 or 3 different types of devices or even more, then one option, of course, is to develop using something like HTML5. And if you develop through HTML5, you got a couple of different advantages. The first advantage you have is deployment. The age-old advantage of deployment on the web, you still get it. Because you access the application and it's on your machine. You update the application, next time you use it, it's on your machine. So there's no pushing involved to your devices. That's a big benefit, isn't it? The second benefit is that everybody can use the application and you're not tied to the specific device because it's through the browser, through the devices, through the browsers. It could be through a desktop or through a mobile device, depending on what you're trying to do. You may have to change the look and feel of it, but once you conform to a particular real estate of what you want to display, there is a way that you can just communicate that. But there's still one problem with some applications. This is somewhat of a narrow area, and that is you have the application through the browser. The one thing that native applications can do really well is they are native. They are on the device. So I could be in the airplane, and I can put it in the airplane mode, and I can still use the native device. Sure, I cannot connect back to the server, but the native application is available to me for me to use to the extent it will allow me to use it. I can use different features on it. On the other hand, if I connect using a browser to a certain site, and I'm navigating through the browser, and I lose my internet connection, either by my true will or because I'm traveling around, then what happens? Now all of a sudden I don't get connected to the application. And that is frustrating, especially if this application is very valuable to me as a user. Now, I've got some, let's say for a minute, there's a company that is going to give these devices to their employees, and they walk away to various locations, and they are monitoring certain things that this company has in various fields. So they may have, for example, utility devices through the city, and they need to maintain it. Or this could be oil refineries that are going to the field and calibrating devices. The geolocation is extremely powerful, so based on where they are, they click on it, immediately brings information about the device or the environment where they are in, and pulls context information. But there's also times when they walk into a situation like in a mine, or I live by the mountains, so a lot of times I would go up the mountain and I would not have any connection for about 6 or 7 hours as I hike through the mountains. And there are park rangers who constantly go through the mountains, and they have to look for animals in a certain area and report it. They may have to look for trees that are down so they can clear it out, or there may be a forest fire they want to report. So all kinds of the stuff they want to do, and this is very easy for them to carry a small device on their hands, and if they can just use the application and say, oh, here's a problem in this location, and they can quickly report it. But the problem is you don't have internet connection. So what can you do? Well, the answer is you could go native, or what if a web application can work offline, and that is when it really becomes powerful. So how does it really work? The way this application works is it contains kind of like two parts to it. Let's quickly understand what these are at a high level, then we'll come down to the details after that. The first thing is, at a very high level, your browser makes a request to a page. Like it normally does, it makes a request to a page. Now, when the request is made to the page, it starts downloading the page to your browser like it normally does. However, you would encode your page just a little bit to indicate that this is an offline application and not just an online application. As soon as the browser sees this, an HTML5 supporting browser says, you want me to run this offline at times, so it forgets for a moment to download your application and its pages, and instead start processing this manifest file, and downloads the details of the manifest. And the minute it brings the manifest, a manifest basically gives details about the way this application should work in two modes, an online mode and an offline mode. In the online mode, of course, you go get the stuff from the web and work with it. In the offline mode, you have to cache certain files that it needs to use and work with it. So as soon as it makes a request, it downloads all the offline files locally to the browser, much like how your browser caches the pages on the client side when you visit a certain website. So once it downloads all the pages to the client side, then it continues to download the pages like it's in a normal mode and continues to work. Now, after this point, you interact with the application like you normally do. But at some point, you disconnect from the network, and the browser says, oh, now I'm no longer connected to the network. Let me switch over to the offline mode. And the minute it switches over to the offline mode, for the files that you are using, it looks up a little table or a map. If you're using file F1, use another file, which is the offline version, and it would quietly bring the offline version and provide it to you. Now, of course, as a programmer, you have to decide what that means to you. You cannot obviously talk to the network from the offline files, so you start programming in a way that you can handle this offline mode in a way that you're providing meaningful feature to the user, maybe in a reduced mode, depending on what they're trying to do. But imagine for a minute, if you can build the application where almost everything happens locally on the machine, and only when needed, the application is going to connect and push the data to the server. Then pretty much in your application, you can get almost 90% of the feature or more because you do most of the things locally anyways. So that is something you can quickly build in fairly easily into the application and leverage both offline and online application. Now, for us to be able to do this, of course, we want to store data locally. So I'm going to deviate from the topic for a few minutes, talk about local storage, then we'll come back and look at the offline facilities after that. So let's talk about how do you store things on the client side. There are about 3 different ways to do this. I'm not going to talk about all the 3 ways. One of them, for example, is to use a real database on the client side. You could do that. But some of these technologies are still kind of evolving. There are a few questions about their stability, maturity, and so on. But the one that seems to be a little bit more mature on the forefront is the so-called local storage. Now, clearly there are other options. I'm not trying to tell you that there's no other option. But I'm just going to look at one option here, but feel free to explore other options if they make sense. But the main idea is you want to store the data on the machine. So what does a local storage do? Well, a local storage basically says, I'm going to store the data on the user's machine. If it's a desktop, it's on your desktop. If it's a computer, it's on the computer. If it's a handheld device, it's on the handheld device. Who is responsible for storing this data? The short answer is the browser is. So the browsers that support HTML storage is going to store the data. Where do they store it? It's their business. They store it in usually some user profile directory. And if you spend enough time, you can dig in and find out where they store per browser. But they store this data on the local machine. And once they store it on the local machine, you can then, of course, pass this on to the server at another time whenever that may make sense. Let's look at an example of how this is going to work and how we would be using this. So let's get to this example. I have a little sample file I want to start with, and we will see how we would use these local storage and make use of it. Now, there are 2 words we need to be aware of, a session storage and a local storage. And the main idea behind these is that a local storage basically says that it will store the data locally on the machine. A session storage means it's going to be only in the memory. It's not going to go away and persist in the hard drive. So a session storage is useful for a live interactive session with the user, but the minute you close the browser, it goes away. A local storage, on the other hand, is you are interacting with the application, it stores the data on the disk, you quit your browser, come back tomorrow and start again, that data is available to you and you can continue to use it. So that is basically a local storage. How would I go about using some of these things? Let's say for a minute that I want to just keep a name of a person. That's all I'm going to say. So I'm going to say name, right? So in this case, I'm going to create a little text field. Keep it very simple. Let's say this is my form, but I don't care about a form. So we say input and type equals, let's say, text. Now I want to store this and I want to bring it back. So we'll say on change equals, and then we will simply say save. So I'm going to save every time you modify this data, and I can also provide you a time when I can bring this back up and use it as well. Again, I'm not putting any bells and whistles at all. I'm keeping it extremely simple in this case. So now that we have this, I need a script, of course, to store this information. So we'll create a script over here. And what do I want to do in the script? I'm going to put away the script into a function. So we'll call it functions.js. And this functions.js is where I'm going to say save data. Let's call it save data. And what is this going to store? I want to store some data, which is the name that I want to store, right? Again, keep it fairly simple. Now, I want to store the name. So what I'm going to do here is you're going to call save data. And in this case, you're going to send to him this dot value, because that's the field information I want to save. So how would I go about using this? I called it functions.js. And of course, I need to call the save data, but save data is already there in the function. We can simply call it, right? So this is where I'm going to come in, and I'm going to say, let's say saving, right? I want to save this data. So here is my page. Let's take a look at the page itself. So I'm pulling up the sample.html. So here is the name. I'm going to say here is Raj, hit the tab. And I want this to recognize that I changed the data, and I want him to go ahead and call this function. So it's called functions.js. So did I make a mistake in calling this? Save data, that's right. So date, not date, save data, thank you. So that says that we are awake, that's good. So let's go ahead and run this again, and I'm going to change this, right? And there we go, it is saving. So what do I do? Where do I save it? That's the easy part. There are a couple of different options available to us. Right off the bat, you can say local storage, or you can use the word session storage. Either way is fine. Now, if you use the word local storage, it is going to be on the machine, like I said. Session means it's only in memory, it's transient. So let's say local storage. You can say set item, and then you could say, the name if you want to. And then you could specify what the value is, and you can store it like this. So this is basically saying, I want to store this data, the name, when you call this operation. So if I go back and refresh this page, now that I put the data in there, and it should supposed to save it. Well, did it save? Well, it depends on the browser that you're using, but you could ask him for details about what he stored by simply going into the tool. Usually most of the browsers have a developer tool, and I'm going into the web console right here, and let me kind of pull up the web console here a little bit so you can actually see this better. So in this web console, I'm going to ask him to display the content that he has stored in here. So I could say local storage, and then we can just take a peek at it. So this is purely a tool to get visual into you. If you're using Chrome, it's got similar features. If you're using Safari, it's got similar features. If you're using other browsers that will remain unnamed here, that's got similar features depending on the support. So if you go look into this, you can see that it contains some data in here, things I've saved before, which I can clearly clear out by calling clear, and that, of course, goes away the minute I clear. And then, of course, I can go back and change this if I wanted to, right? So, I can say over here, save a data. I can come back here and take a look at it one more time, and we can look at the local storage and look at what data it contains. So the idea behind this is that, I think I cleared it again, but anyway. So the idea really is that you're storing the data, and then you can restore it by looking at the data that it gets stored eventually. Now, where is this stored? Like I said, it's stored by the browser, so we don't have to care about where exactly it sits, but it is sitting somewhere there, and you can take a look at the data. It's stored right there. A couple of small details to iron out. The first detail is we simply are storing one variable here and a string. For most part, if you're using this approach, you're storing strings. There are other approaches, like you can use a database per se, then you can store other types of data, you can get access to SQL and stuff like that, but in this case, you're merely storing the string. But that doesn't mean you can only store a string and nothing else. You can store a string as underlying representation. However, you could get an object tree on your hand, and the minute you get an object tree, you can go to this object, you can quickly get a JSON representation of this object tree, right? And the minute you have a JSON representation on your hand, you can call the method that says JSON to stringify, and that gives you a string representation of the JSON object, and then you can store the string representation into the storage. Then when you're ready to pull it back up, you can take the string representation, and you can say parse JSON, and then now you got the object tree on your hand, and you can continue with your operations. So you can still store and retrieve objects if you're interested. You could still do that. So that gives you some capability to go back and forth with this. Now, continuing with this example, while you can write code like this, you can also minimize the effort just a little bit because of the dynamic nature of JavaScript. You could even do this. You can simply say the name equals and store it as if it's a property directly on the object. So you can remove some of the ceremony around this code, and you can store the property just like this if you're interested in right here. So let me go ahead and save that and refresh this page and go back here and try this and try to save another name here. And I go back and look at the local storage one more time, and we can see what it contains at this point. So there's a local storage. I changed the code, and hopefully it took effect, and we can see the new information that's being stored. You can see that object is right there in the memory, right? So that's an example of how you can store it. But wait a minute, you stored the data, but what about restoring it? Where do I get that from? Well, that's pretty simple as well. You can go back and write a method called load data. And the load data, of course, needs a couple of things, right? It needs to know where to put this data. So let's go ahead and say the field where I want to put this. And in this case, I can say field.value equals local storage dot the name. So I can just reverse it, right? I can get back the data, and I can stick it into this field wherever I want to put this. And where would I call the load data? Well, I could call that in my script if I wanted to. So I could go back to the script here, and in the script I can say, for example, when this loads up, I can say go ahead and load up the data at this point. Let's say script, and in this case I'll call load data, and the load data is going to be for document.getElement by ID. And I want this to be, let's call it the name. So I'm going to name this as the name. So this is going to be ID equals the name. And so we are asking him to restore into this element. Now this is going to get called when you load up the browser in the first place. So I go hit the refresh button. Notice it says undefined. Why does it say undefined? It went in and tried to pull the data, and for some reason it didn't pull the data at this time. So I'm going to go ahead and change it to what did I do here? This one here. And you kept quiet. You didn't even tell me this. Okay. Now they are telling me. So local storage. All right. So that basically is the data. I refresh. You can see that's working, right? Excellent. So this is like, you know, there's the data is getting stored. You're restoring it. But what if I bring up another browser instance? Now, this is the same browser, by the way. But notice that I'm able to see this data across the two browsers. If you bring up Safari now or Chrome now, obviously you won't see this data because this is very specific to the browsers. Of course, you may say, oh my gosh, then if I'm using multiple browsers, how do you deal with it? Well, one thing you got to keep in mind, you guys are the programmers, but the world is not full of programmers. Sometimes we hope that it was, but it's not, right? So grandma and grandpa don't use 10 browsers. So usually people use one browser most of the time. And in fact, they use a pathetic browser that will remain unnamed here. But most of the time though, right, they use one browser. And on a device, by the way, you normally use one browser, right? So it's not a problem most of the time. This kind of reminds me of an experience. I was teaching a course on HTML5, and I developed a little application, and as soon as I developed the application, I put it on my website, and I said, guys, go ahead and try it. And everybody in the room got their mobile devices. They were like trying on it. And half the room was iPhone people. They tried it, they played with it and said, yeah, it works. So it was kind of a dull moment for them. And then the rest of the room was Android people, and they kind of tried and said, yeah, that works. There was one guy, always there's one guy, right? One guy in the room, he said, wait. And he's still working on it. So we all were talking and said, are you done? No, wait. And finally said, what are you doing? He said, well, I'm using a Windows phone, right? And then we said, okay, you know what? We'll do asynchrony here. Call us when you're done. So we moved on. Like 15 minutes later, we heard this big noise. He said, yes. We're like, what happened? It works. And we said, that's cool, but it took you 15 minutes. Why? Oh, it took me some time to download Opera. So the point really is that you really need to have these devices. You need to know which browser to use. That's still needed, right? But most of the time, you don't have to worry about that kind of problem. But as long as you have a fairly decent browser to support, you're fine. But what would be really useful is this. If you are in a web application, you want to provide a well-rounded experience for the user. So if they're modifying a certain part of the page, and then they're modifying another part of the page, it would be really nice if you keep the views consistent. If you don't, what happens? The user is kind of aware something is broken. And programmers are very good at this, right? What do? We constantly hit refresh, right? And we know what to do. And people look at us and say, what are you, right? They don't say, who are you? They say, what are you? Because you know how to navigate the application of the browser. And you say, well, that's what I do at work, right? I constantly refresh browsers. But for real world people, that doesn't help. And that leads to inconsistency. People don't understand how things work. So how do you really manage that? Well, it would be nice if we can support some event handling. So notice what I'm going to do here. I go to the application now, and in this case, right after we do the load, I'm going to simply add, I'm going to say window dot, and I'm going to say add event listener, and the listener that I'm interested in registering to is an event called storage. So, and what am I interested in doing? I'm interested in loading the data, obviously. Now, when am I going to do? Right away. And I'm going to say false, meaning don't go through any other process. Well, there's a slight problem, though. Well, the problem is the add event listener is going to call a function. But what is that function? The function is called load data. But the load data requires the field in which you want to load. So this will not work, by the way. And the reason this will not work is the load data that you call requires the field, but the action listener doesn't know what that field is, because it's kind of like this event, right? It doesn't know anything about your page. It simply says, hey, look, something changed. And what changed? That's your problem, not mine, it says. So how do you deal with it? Well, it turns out it's not really that hard to deal with. Rather than putting the load data here, we will call it as simply respond to change. So we'll just call it as respond to change. Now, what is respond to change? Respond to change is just a function. So we'll just call it as a function. And in this function, all that I'm going to do is simply call load data and pass this information to him, and so he can use it. So it's just a level of indirection. And we're able to use lexical scoping, and by that we're able to go back and access that, so that becomes very helpful. Well, if you do that, you can quickly realize that you don't want to duplicate code, so you can get rid of this right now, and you can simply come back here and say respond to change and call that, or you can give it a better name if you're interested in. So now that we modified that, let's go ahead and refresh this page and refresh this page. So we have these two views sitting next to each other, but this could be two different parts of the same application as well. It really doesn't matter. So now I go back and change it, and you can see that it keeps those in sync. And that is something very useful to do. But this could be another part in the same application, but you can respond to it. But the event that I just added, by the way, is smart enough not to inform you about the change itself. If you're programmed with things like observer pattern in Java or C#, You know the pain of doing this. This is a boomerang effect, right? You create an event, you have to say, if the event source is not me, then do this, which is a stupid code we have to write. You don't have to do that here. It's smart enough to know that you created this event, it won't call you back itself, right? So that is taken care. But as you can see, it clearly keeps change in this case, so you don't have to manually be doing the updates, and you can simply say here that you want to change over here, and you can see that it clearly refreshes back and forth and goes through, so we can do that. So we talked about the storage, the items. You can remove elements either by calling remove element, you can also do clear. You can do these in the code level, by the way, so if I want to clear stuff, just go back into the code and say, clear, and at any given time you can say var clear equals, and then you can write the function to do the clearing itself. You could say local storage.clear, and then get rid of the entire storage. That's one way to clear it. You could also call remove items. Be also careful that the user can remove the data at any time, so you don't have control over that. So if the user decides to blow it away, the data goes away. So don't put anything that the user just cannot afford to lose. Or at least kind of tell the user you are stupid, right? That you blew away the data. Or at least give them some kind of information. If the user randomly goes and deletes stuff, it'll be lost. What about security? Well, the user is going to store the data locally, so they could potentially see it. If you don't want them to see, there's a very easy way to fix it. Don't store it, right? So if you don't store it, they cannot see it. But if you say, I still want to store it, what do I do? Well, you could probably encrypt it and store it, right? That's going to require a little bit more effort. But how do you encrypt and store it? If you're doing two-way encryption, it's not as secure as one-way encryption is, right? So you got to kind of use plus and minus of those details. Also, you only have access to 5 megs of data on the client side. What if you want more than 5 megs? The short answer is don't be greedy, right? Be happy with the 5 megs. If you really want more, the specification says, you know what, be happy with 5 megs, but some browsers always say, hey, can I ask the user to give more space and may allocate more space, but don't rely on it. So if you exceed the space, you get an exception at runtime, and of course you have to handle that exception. If you don't handle the exception, ugly exception messages are going to pop up, which is not going to make a friendly user for you, right? So you don't want to do that either. So those are some of the things to keep in mind. All right, so we looked at the storage. That is great so far. You can also store JSON objects like I mentioned. You can find out how much data you stored. You can get through all the key values. So you can do some of these things. You can also look through the console. I showed you example earlier. And then I also showed you the event handling as well. Let's get to the offline mode. How do we do this? Well, a couple of things you need to be very careful about. So let's quit this for a few minutes. We'll come back to this. Let's look at the offline operations itself before we go any further. So what I want to show you here, first off, is just a little detail about the web server itself. I have a little web server running here. I'm going to restart the web server just for us to play with. So let me go ahead and restart it. Now, I'm going to go back to this page, which is the sample.html page. And in this page, I'm going to put a little declaration at the very top. So here is my sample page, as you can see. And in this sample page, I'm going to go to the HTML part, and I'm going to type this part right here. So I'm going to create a manifest equals my manifest.app cache. By the way, you can call this whatever you want to call it. So it is an app cache. So go ahead and give a good name for it, right? I just call it my manifest, but you can call it whatever that may make sense. Typically, this could be your application name or whatever that you want to specify that name. Now, what does this mean, by the way? When you put this manifest in here, it tells the browser that when it starts downloading this page, it immediately recognizes this manifest, and it quits downloading this page content and doing work with it, and immediately downloads this manifest file. And the manifest file is kind of like a table, if you will, that tells the browser, hey browser, you need to run offline. Here are the files you need to cache before you go any further, before you start using the app. So at this point, the browser is going to start downloading all these pages and store it locally. And the minute it finishes downloading all of this, it says, I am ready, and goes back to process the page. Now, there is one small detail we got to be very careful about. If you just try this on a server, And you will sit there and kind of scratch your head and say, why is it not working? And the reason it's not working is the browser really doesn't know that this is a manifest file. Why doesn't it know it? Well, you did say app cache in the end, but unfortunately, you know how the browsers work or don't work. The browsers don't care about file names after all, right? Because you could create your own file names. What the browser really cares about is what is the content type. If the content type is a certain type, it immediately recognizes that. It doesn't matter what the extension is. Well, the first question you have to ask is, what is the content type of app cache on your web server? This is your web server you're using for development. This is the web server you're using for testing. This is the web server you're using for production. All of those must use the same MIME type. Otherwise, it may work in development but not in testing, or testing and not in production. It is a pain in the neck, but you got to deal with it. But there is a good news. There are different ways to solve problems. One way to solve problem is shooting in the dark, right? And another way to solve problem is to hope, right? Hope is a good thing, but we don't want to do that here. We need really good ways to find it out. Again, take very small step, iron out single detail at a time. So notice what I'm going to do here. I'm going to call this my manifest.apache, that's app cache rather. That's what I'm going to call it. So I'm going to create a file here called my manifest. Let me make sure I'm in the right directory here. Yeah, so my manifest dot app cache, right? So that's a file name that I'm creating. So what do I want to put in that file? Well, we'll decide what to put in that file in just a second. So let me go ahead and quit this guy for a second. So let me bring up my manifest. And I'm going to change this file a little bit. I've got a sample file I'm working with, and we'll change it. So I've started with a little thing here called cache manifest. And here I'm going to say, what do I want to cache? Sample.html. So that's one file I want to cache. I also want to cache offline functions.js. So those are the two files. And then I'm telling him that as a fallback, anytime he sees functions.js, fall back to offline functions.js, right? So that's the name I've given to this file. And then, of course, I say network, go to network for everything that you access if you are connected. So this is the manifest file. Now, what does this mean? Cache manifest is just a little thing to say that this is a manifest file when he reads it. The cache basically says, go ahead and download the sample.html, go ahead and download the offline functions.js, bring those to the client side, keep it ready. And then it says a fallback. Anytime a user makes a request for functions.js, go to it if you are connected to the network. But if you're not on the network, quietly use offline functions.js without any clue. Of course, this relies on we, the programmers, doing the right things, right? So you would do tactically the right things on both ends. And then once you do that, things should work. But unfortunately, this is not enough. Why? Let's see why this is not enough. This is called as my manifest.app cache. But let's go over here. And what I'm going to do is use a really useful tool. By the way, we all download stuff from the web. We do that constantly, right? Now, I do as well. And a lot of times, I may find a link to an article. I may click on the link. A browser opens up. And then you are clicking on the browser and saying, save it to the file, and you're doing it. But sometimes that is just too boring, right? And it is too many clicks. And more clicks we make, it keeps reducing our intelligence. So instead what you can do is you can just grab this link and you can use a curl program which becomes very easy to use. So what does a curl do? A curl basically is a command line program that downloads stuff off the web. So you can, for example, say over here, curl, and you can specify a URL, whatever URL you want to, and then just dump it to a file dot whatever, right? So this will go to the URL, download the content, and dump it to the file. So this can be very useful, especially if you want to download files quite, on the side without really going through a browser and all those stuff. Let it do the job. You can even automate it. Well, we're going to make use of this very nicely in here. So how do I use curl for this purpose? Why do I want to use curl for this purpose? And the reason simply is that if I use curl, it can give me some details about what this file is. So curl, and where is this located? So first of all, this file that I'm going to use is located on my web server, right? So I call it sample offline. So if I go to the browser for a second just to see if this file is present, so I'm going to say localhost, and this is going to be sample offline app, and then it's going to be sample.html. That's the page that I'm going to. You saw that the page is showing up, right? But I'm not going to go to that page. Instead, I'm going to say, go over to sample offline page. So http that/mymanifest dot app cache, right? That's a file that I'm asking him to look at. But I'm going to say a -i option. So when I run it with -i option, it immediately gives me some data about what it's downloading. In this case, it tells me it found the file. Make sure it says 200 OK, by the way. There are times when I mistype the file name and I'm like, this is awesome, but no, it is not, right? So make sure it got the file. So 200 OK tells me the date over here. Then it says server is whatever the server is on my machine. It says last modified on that day. And then it says the last line is your clue here. Notice what it says. It says content type is text/plain, meaning this is broken, right? This will not work because the browser is going to download this file and say, it's a text file, and throws it away. So it doesn't know it's an app cache. Just because you named it app cache doesn't mean anything. Making sense? So once you find this out, you can go fix it. So what I'm going to do now is I'm going to go over to the MIME types file, and this file, by the way, is a file on my server, and on my web server I changed this to text/cache-manifest app cache. So I am saying when you send a file with the extension app cache, do not say it's a plain text anymore. Instead, mark it as a cache manifest. And now the browsers will know that this is a manifest file. Am I making sense? So this file is the mime.types. It depends on the server you are using. If you're using Apache servers, there's a file called mimes.types. If you're using other servers, you got to go find out what that file type is. It could be either through a file, or some servers may give you a UI to modify this. Whatever it is, figure out what it is to modify it. Once you change it, make sure it does take effect, because if it doesn't, there's no point doing it. So in this case, I'm going to restart my server. And once I restart my server, the next thing, of course, is to make sure this is working again. So I run this, and notice that difference this time. It says that content type is text/cache-manifest. So now my browser should recognize this manifest and do the magic that it should do. Making sense so far? Right, so keep that in mind, otherwise you'll waste a lot of time and wonder why things don't work, and it's pretty frustrating when that happens. Alright, that's good so far. Now let's get back to this and see what we're going to do. I'm going to go to this code for a second, and let's change a few things to make a little easy for us to work with. We already saw how to store stuff and restore stuff. We can continue with that. But instead what I'm going to do here is get rid of these guys for a minute, and I'll simply over here say, call a function info, and we'll just call the function called info. Where is this function called info? So I bring up functions.js, and I'm going to write this function called info equals function, and here I'm going to simply alert, and I'm going to say connected, right? That's all I'm saying right now, connected. So that's a very trivial function, but let's start with that. Excuse me. Now let's go over to the other file that I wanted, which is the file called offline functions. So I'm going to copy functions to offline functions.js. I just made a copy of the file, right? But in reality, it would do a lot more work than just simple copy. So offline functions, in this, I'm going to say not connected, right? That's all I did. So it'll alert not click. And then we will say, in this case, we'll call this method info. And then, of course, we'll call it click me. All right, so let's go take a look at the page. So open sample.html. Actually, let's do something else. Let's bring up Chrome here, and then take a look at this. So this is Firefox. Leave this alone for a minute. We'll come back to that. Let's bring up Chrome. And Chrome can give you a little bit of detail as it's downloading the page, which can be fairly useful to look at, by the way. So let's go to the developer tool over here in here. And then let's ask him to show the developer tool. So that is kind of displaying the content down here. Let's go to the page, the sample.html page. And as soon as I visit the page, I can take a look at some of the details that this guy can have. So let's make sure that it's using the right version of the file, first of all. No. So I need to go through the browser, isn't it? So http:// so localhost, localhost sample file. I'll call it sample.html. So what happened? Notice as soon as I went to the page, Chrome tells me it found a master app cache file, and it says downloading event. And it starts downloading the sample.html, offline functions.js. It also found a sample2 on my file. It brought that up. So it brought a bunch of these. It downloaded those. And then once it downloaded it, it says that it's ready with the event, and it moves forward. So if you are listening to the output here, you can see that it's actually downloading this. This is another thing you will notice. If you did not configure the MIME type properly, when you visit the page, you won't see these events. So you can say, that's not working. Why? Then you can look at the curl and find out what the type is. So far, so good? So now it's cached it in, and it's downloaded on the client side. Now we can go about to use this. How would I go about to use this? So let's go back over here, and I click on Click Me, and it says connected, as you can see right here, and says that we are connected. Now, that's great so far. I'm going to go back to my server here, and I'm going to stop my web server. So I just stopped my web server. It's no longer running. Now I go back here to this page, and it tells me that it couldn't connect to the server, and I click over here. Notice it says not connected now instead of being connected. And we didn't change anything on this side, right? So it says, oh, I'm on this page, and you are connected. I'm going to use functions.js. But of course, we got to make sure we line these things up properly, right? All the functions you want to have available should mirror in this offline function as well. And then you have them both in this case, and then you can say, if I'm connected, use the function in the connected mode. If I'm not connected, quietly switch over to this guy and start using it. And it knows which one to use based on what you're connected to. So this goes from connected to not connected. Now what is the next thing to do? You can say, oh, now that you're not connected, by the way, why don't you store the data locally, and then when you are connected, you can send the data over. Now, so a couple of options on your hand. We already saw how to write the code locally, right? That's no different. How do you send the data to the server? That's very simple too. That's an AJAX call you would make. Now, the problem with this approach is, if you go this route, you would quickly dig into a rabbit hole, and it becomes really hard to maintain your code after that. And a better way to do this is, if you're going to support this, why don't you work in offline mode by default, even when you are connected? Just entertain the thought for a minute. What's going to happen? So as the user starts interacting with your app, you automatically keep storing locally. Then your code entirely is the same. It doesn't matter when you are connected or not connected. You only store locally. But then, if you are connected, you can immediately sense that you are connected, and you can push the data from local to the remote right away. And if you're not connected, you can postpone that push to a later time. If you go this route, you will have less code to write. And that's a good thing, right? Because if you have less code to write, there is less code to maintain. There is another big advantage, by the way. The code you did not write has the fewest bugs, right? I mean, you cannot beat that, right? You can never have fewer bugs than the code you did not write. And so you didn't have to manage two sets of code. That is much better. So always store it locally. But how do you know you are connected or not? Well, that is a bit of a pain in the neck. Now, I refresh the page quietly behind the scene here, by the way, but you don't want your users to do it. Certainly I wouldn't do it if I'm creating this application for real. So I need to detect if I'm connected or not. You may say, oh, you could do that very easily. There should be a function you can call, and that tells you that it's connected or not. Wrong. There is no such function. And even when there are some functions available, they lie to you. So there is really no easy way to find out whether you're connected or not. So you may say, here's a bright idea. I'll turn off my internet connection. That doesn't work, by the way, right? It doesn't sense to you and say you're not connected. You could try to put your device in airplane mode. That doesn't work either. So what do you do about this? Well, it turns out there's actually a fairly simple way to know whether you're connected or not. Why don't you just make a very simple AJAX call? If you make an AJAX call to a dummy page you have on your server, and you would make an AJAX call to it. By the way, when you make an AJAX call, there is one small caveat. The minute you make an AJAX call, your browser caches that page. And the next time you make an AJAX call, it pulls it from the cache. Now you're in trouble again. You are disconnected, and it still says you are connected, right? So what do? Well, it's actually very simple. Make a call to the AJAX call to a page, but simply put a question and a query string. This automatically forces a refresh back to the server all the time. So now you say, using the AJAX call, I'm going to go fetch the page. If you're connected, you get the page back that says you are connected to the network. Do the push up the data to the server. If you're not connected, this call fails. And you handle a 404 request, right? And then you say, oh, now that I'm not connected, I'll continue to store the data locally and not go to the server. So you can handle that fairly easily by just looking for a particular page on the server and decide whether you're connected or not. And at that point, it is purely coding to push the data to the server and then have it deal with it on the server side. So given this, how do we proceed with this? So going back to this, you have to first start out by defining a manifest, and let's say that app cache, whatever you're going to use as the app cache in the beginning. So that tells you where you are going to go. And then you need to create the manifest. Now, this is great so far, but the problem is, oftentimes, we want to make changes to stuff. So what is going to happen when you make a change? Well, you can see that you have a cache manifest right here. And you also have a cache where you list all the files you want to cache. That is a good part. Then you also have a fallback that tells you want to fall back on this file name. You can also specify directory names and say, for all the things in this directory, go to the files in this other directory. And then, of course, the network tells you that you want to get all the files from the network when you're connected. However, we already talked about this. What if you are going to make a change to the application? It turns out, unfortunately, it is not as simple as you would like it to be. So if you make a change to the code on the server side, you would want this to be pulled back onto the client side. Let's go back to the application for a minute and take a look at it. If I go back and restart the application one more time, in this case, the server, and I'm going back over here, it is saying that it is checking for the app cache event, and it says there are no updates, right? So that's good, because I didn't make any change. Let's now sneak around, go to the functions.js, and go to the offline functions.js, right? And in this file, I'm going to change it to not connected and a 2 exclamation mark. Just a small change I made, right? And I saved it. Now I go back to the browser, and I hit the refresh button, and notice what it did. It said, there is no change. It's like, what do you mean there's no change? I did change the file, right? The one thing you should never do is argue with the browser, right? That's when you know you need a break. You say, okay, you're not downloading, what's going on here? Well, it turns out, unfortunately, it doesn't know anything about these files on the server. Why? You could remove files, you could add other files, you can change files. And a browser cannot be checking for these every time because that is expensive. The number of times these are going to change is far less than the amount of time you're going to spend using the app. So from the efficiency point of view, they don't want to do it. So all those reasoning are a good reason. But unfortunately, how do I know that something has changed? The way you know that something has changed is by physically changing the manifest file. So what you have to do, unfortunately, is if you make change to any file on your system which is related to the application, you got to go to the manifest file, and in the manifest file, you got to maintain a little change. So notice here I said version 1. Now I go back here to the browser and I refresh. Notice it quietly refreshed the whole thing now. Now, this is kind of silly, by the way, because you're just keeping a comment here, and you're changing the comment. And now when you change it, it reloads the whole stuff every time. But the next time you can notice it doesn't load up now. But of course, if I make the change to this comment here, it is going to load up this one more time. You can see that it's pulling it back. So the bottom line is this. It doesn't look for your files. All that it looks for is to see if the manifest file has changed in its content. So for that, keep a silly comment block, and then keep changing the comment number, and that is the way you would propagate the fact that this is modified, and you can pull in the change. If you don't do this, it doesn't pull the change over, so just keep that in mind. So that is basically how you would communicate the change itself. So after this, the next step, of course, is there are certain things you may want to do on your client side, right? For example, whenever an update happens, there are things you may want to do on your client side. Maybe you want to gently inform the user that we have made some changes, by the way. Here are some new features for you. Maybe the user can go look at it. Or maybe there are other changes you want to make. Like what? Maybe you change the data type or the way you store the data in your upgrade. And now the user has an old stale data maybe, and maybe you want to do some modifications to it. I don't know, whatever that may be that you want to do. But how do you know to tell the browser to do some extra work when it gets a fresh copy of the application? Well, the good news is we can write JavaScript for it. And the way you write JavaScript is, just like how you added an event for the storage, you can add an event for the app cache on update ready. An app cache on update ready is an event that it is going to call. And anytime it loads a new app cache, it's going to go call your event, and you can handle things in this method, and you can do whatever notifications you want to do, upgrades you want to do. You can do all of those fairly well. So that is basically how you would communicate this. And then finally, of course, if you are connected and not connected, like I said, you would have to push the data from the local to the server, but I would say you would want to use Ajax to push it. The key here, like I mentioned, is try to minimize the effort, and by storing it locally, and from time to time you detect whether you're connected, and then you can send it. But when is a good time to do it? The bad approach, in my opinion, is you are expecting a user intervention to push the data to the server, right? Because if you do that, you are waiting for the user to do this for you. It becomes unnatural. The user may not do it, or there may be other issues with it. Instead, make this as a natural flow through the application. Are there positions where in the application where a user will cross a particular path of a workflow and insert a check you during those times? And if you see that you're connected, then just put a task on your event queue that says, go push the data to the server. Let the user continue with the work. When the user finishes the work, the event you put on using the set timeout can wake up and say, I'm going to go push the data to the server. I wouldn't put a method that keeps checking periodically, too often at least. I wouldn't do that, but I would make it as part of the workflow to detect whether you're connected. And then if you have a data locally saved, and then you are connected, just put a little task on the queue and say, come back and do this, and it can empty the queue and empty the local storage and send the data. This is a very powerful feature, as you can see. And the place where you would use it, of course, is if I really need an offline storage. Now, offline storage, I gave an example of when I would use it. When I lose connectivity, if I'm like a park ranger going up the mountain and I want to collect data, or I go through an area where I won't have internet connection, or I'm going through tunnels and I lose connection, those are the good times to use this. Another reason to use this, by the way, but not offline, but the local storage, would be to store preferences of the user. In that case, of course, you're not using the offline facility, you're only using the local storage facility, but the offline is really useful when you want to really work in the offline mode, in disconnected mode. There are quite a number of applications that can benefit from this, but it depends on the type of application you are developing. Like I said, I have some clients who are very heavily into this because they do have devices that they need to carry around, and they definitely wander over in areas where they have either very poor connectivity or almost no connectivity. So this is something that is very valuable for them and have benefited quite a bit from it. That's all I have. I hope you found that useful. Thanks. Try to learn about a few things we can do. So the first thing is, of course, JavaScript is a language that's very fascinating. It's fascinating for several reasons, more than one reason. It's a language that was created right about the time when Java was created, give or take a year or so. But nobody thought that this language would become so ubiquitous. And it's where browsers kind of got together and decided to support it, not by a committee decision, but out of just the sheer will to have something working. And it's a language that has been around for such a long time. Most of the people who have written any kind of an application on the client side have often used JavaScript, because right now we could argue that's probably the only language in various flavor, even though in different flavors, that's available on the web. But it's also a language that a lot of people have kind of picked up along the way, but in not a way that they might have done for other languages. I mean, I think most of us can admit this, right? You probably put more effort to learn the other languages that you program in as much compared to JavaScript itself. Is that a fair statement? Yeah, you put more effort learning Java, more effort learning C#, and somehow you think it doesn't deserve the time and effort to learn JavaScript. But yet JavaScript is very ubiquitous. We use it a lot. And it's a language that we kind of looked at, we feared it. And sometimes also, it changes by the time, by the way, but I'm sure there was a time when people didn't want to go around and tell that they were JavaScript programmers. They would much rather say they were other programmers, and they'd still have to do the JavaScript from on the side, right? But that has changed a lot. It's very different world today. And surprisingly, one of those changes that we did not see coming is all of a sudden, not only is this language powerful and popular, but it's a language that is no longer bound to a browser. A few years ago, if you asked, I have a little JavaScript I want to try, how do I do it? You pretty much will see people open a browser. And then they would write this little JavaScript and run it in the browser. It was painful. And we had to run this in the browser because there was not good enough way to run this outside the browser. But that changed very drastically over the past few years. You had implementation of JavaScript in various things, like JVM had an implementation within that. You could use it. And there were other tools. So you had a freedom from the browser. But not only do we have a freedom from the browser, but all of a sudden, we are talking about writing JavaScript on the server side. And just to kind of say, you know, how convincing this can be, I do quite a bit of application, server-side application with things like Rails and Grails. I write code in those tools and languages. And if you ask me, hey Venkat, go ahead and build this, I could probably build something up, you know, relatively small for my purpose within about 10 minutes or 15 minutes in Grails or Rails, if it's a small enough thing to do. But recently I was working with something, and I had to create a fairly lightweight application to serve a certain content. And immediately my thought was, I clearly discarded a few solutions, right? Heavyweight Java solutions, no way. And so my choices kind of boiled down to, I could use Rails or I could use Grails. And I just could not convince myself to use either one of them. And don't get me wrong, I use those all the time. But this particular thing I wanted to do was so simple that I couldn't imagine putting 10 different directories together to do something that small that I wanted to do. And I told myself, what would I want to write it in? And I quickly realized that I could actually do this in about 10 lines of JavaScript. And that's exactly what I did. And I wrote this in about 10 lines of JavaScript. It's a server to serve what I need. And 10 lines of JavaScript I was done. And I had deployed. And you may say, well, didn't it take you time to write the 10 lines of code? And couldn't you have done the same amount of thing quickly in Rails or Grails? Maybe. But I don't have to FTP a directory structure. I just have to copy this one file, right? So that makes a big difference as well. So it depends on what you want to do. But this is something that opens up such a wonderful possibility. So we all of a sudden have a server-side JavaScript. So what is Node.js? Node.js basically is a JavaScript processing engine that sits on top of V8 engine. And Node.js not only just sits on top of it, provides some convenience, libraries, more efficiency, re-implementing certain parts to make it more powerful. But it's a way for you to quickly write some JavaScript and run it and get a feedback. It is also a way to write a full-blown server if you want to write one. So this is a very powerful tool. I used Node.js. It's been a little while since I started to use it. And I can tell you that it was almost an instantaneous love falling into it and said, wow, this is so cool. And all of a sudden, I was just using it without even paying attention to it. And almost any code I write these days in JavaScript gets to run on Node first, and only eventually on a browser, because I don't want to bring a stupid browser to try my code, right? I can quickly run. And even if I'm developing web applications, I'm running my code in Node to try it. If I'm writing a web application and I'm trying to implement a certain logic in JavaScript, that logic gets unit tested. How do I unit test it? Not using a browser and tool related to it. I unit test it using Node and Node unit. So I can get a quick feedback and then I can go back and use things. So it's a very powerful and compelling tool, if you will. You could use Node in a REPL mode if you're interested. Now, in today's world, any language worth the salt should have a REPL. So what is REPL? REPL stands for Read, Evaluate, Print Loop. And Read, Evaluate, Print Loop is, as the name says, it reads the code, evaluates the code, prints the result, and loops. So Read, Evaluate, Print Loop allows you to type a little bit of code and get an instant feedback about the code and go back and play with it. A REPL is very powerful because it allows you to quickly create some code and then evolve it. You wouldn't develop an entire application using REPL. But at the same time, I do use REPL quite a bit when I develop applications. When I'm sitting there and writing some code, and I need to write this code in the middle of an application, and I'm not quite exactly sure what I should do with this collection. What method should I use on this collection? The wrong way to do it is to write the code in the app, save the file, run the application to see if it works, only to say, darn it, that's wrong, and fix it. Instead, leave the window up, the editor up here, quickly open a REPL, type in a few lines of code, make sure it's working, and use this world's most best ever technology called copy and paste, right? And then you copy it from the REPL onto your code, and you got a code that's working. And this really gives an accelerated way of writing code. And I tend to do this quite often. Doesn't matter what language I'm programming in, I'm constantly between my code and REPL, because it gives you the speed. So how does the REPL really look like? It's actually very, very simple. So I'm going to go back here to the command prompt. And in the command prompt, all that I'm going to do is simply say Node. So I'm just starting Node right there. So this gave a little prompt, right? And said, you're ready. What do you want to do? I'm going to say over here, I'm in Node, by the way. So I'm going to say over here, hello, Node. And that's all I'm doing. And notice as soon as I ran it, it says hello, Node. And then it says undefined. What is that undefined? Undefined is what console.log returned. It doesn't have anything to return. It's kind of like your void of your Java world, right? Nothing to define back to you. It gave nothing really back as a value because everything is an expression. It has to return something. It returned undefined. I could say 2 plus 4, for example. And I'm typing and quickly finding out what the value is. I'm saying new date and trying to find out what the date is. So I'm running commands right here in a very interactive shell. And if I want to create an array, I could say array equals, maybe names equals, right? I could say Joe, Jack. I can create some names over here. And then, of course, I can say names.length and try to find out how many names are there. You can start playing with things very easily using this REPL. And the benefit of this is it accelerates your development. You can experiment, play with it. In a lot of ways, the way I envision this when I program is, what would an artist do? An artist is doing painting, and the artist wants to try something. Any artist who is sensible wouldn't try to take paint and put and say, oops, did I do that, right? They're going to have a little canvas, and they try on it, mix the color, get the nice proposition they want, and then they kind of slowly touch up and bring it over. We're not doing anything much different, right? We are evolving things, putting things together. So that's the little canvas on the side is your REPL. And I normally have my code editor sitting here, and I may have a REPL on the side, or I may have multiple windows. You probably saw me switch between windows all the time. And my mind is mentally wired to know where things are. My first primary window would be my code editing window. My second window would be where I'm having my REPL. My third window is where my browser is running, so I can quickly refresh and see my page. So your mental muscle kind of immediately wires, and you don't even think, and you keep switching between them, and you can look at those things. So that is basically a REPL and how you can use the REPL. But like I said, you wouldn't spend serious time on this to write a lot of code at any given time. But you would use this to go back and write a little code and experiment. But how do you then run files itself if you're interested in working with files? So let's go ahead and look at an example of how you would write it. So I don't have any files here, so I'm going to create a sample dot, let's say JS. So I created a sample file. Let's do the same thing as we did before. So I'm going to say here, hello, let's say node. So I just saved it to a file. Now I can go to the command prompt and say node, and I can run this. So rather than just typing node, type the node and the file name. And that says, oh, you want to run the file, and it runs it. Now, of course, in this case, the file didn't do a whole lot. It just printed this. So node quickly printed it and went home, right? It's I'm done for the day, right? It checked it in and went on. It is not running anymore. Of course, it will continue to run if you have started an event loop. Then it says, oh, there's more work happening. There are event listeners waiting, so I better wait. So when you run in a server mode, it would stay up and running. But in this case, I'm running it not quite as a server. I'm just running a bunch of JavaScript, so it runs and quits right away. So that right there, we ran it. But of course, I'm a lazy guy. I'm not going to do this. So to save myself effort, I'm going to just do that. So this basically is running node, and it is doing absolutely nothing different from what I did a few seconds ago using the command prompt. It is running node and the file name. I just wired it into TextMate here, so I don't have to keep running it manually. That's all I did, right? So that way I don't have to switch over to a command prompt and run it. It just runs it from here. But essentially, this is just pushing it to the command shell and running it in command shell using node command, and then displaying the result as a tooltip. That's all it's doing. All right, so now we got that part done. What do we do next? I can put more code here. So for example, I could say person equals, right? And I could create a person. I could say first name. And this could be the first name of the person. I could say last name of the person. And then we could say what the data is. I could say age of the person. And we could then say, for example, a person.first name. I could print the person's first name, right? And then, of course, I could also use it to print the person's last name in here and have that value printed. We could even have methods if you're interested. So person.play, and then we could have a function on the person. So play equals a function. And we could say, in this case, we could say game. And the person may say what they like to play. We could say, for example, I like to play, and then we could say game. So in this case, we could probably call this as person.play, for example, tennis, we could say. And in this case, of course, it's going to call that method play we wrote. So we are essentially executing these functions in here and ask it to respond to it, right? That's all we're doing. So this is essentially running JavaScript in the node environment. You probably noticed a difference already. I used console.log rather than using alert. In the browser, you use alert. Well, you're not in the browser. You are in a server-side mode. This is going to spit out on the command prompt. So rather than using alert, you're saying console.log, and that is printing out stuff. And so depending on whether you are in a browser or whether you're in a server mode, you can use that to display things out. And that's what you're doing here in this case with the console.log. So that's basically how you would run it using a file. But I'm not going to talk about Node.js for a few minutes. I truly believe that if we're writing JavaScript, we better develop the culture of writing unit tests. We are under dangerous situation right now in our field. I want to call this the crisis in software development. It's a crisis because we somehow think we can write code and go home. And unfortunately, it doesn't work that way. It's not about speed at which we can write code. It's about the cost of maintaining the code we create, right? And to me, automated testing is extremely important because automated testing tells us not only the code worked, but it continues to work as we make change to the code. So if we're going to be programming effectively in a language like JavaScript, I don't think automated testing is optional. I would say automated testing is mandatory. And there is only one way to do it, is just to do it, right? And by the way, one thing I hear people tell me all the time is that they would do automated testing only if their managers allowed them to do. This is so easy, by the way, because then we can go home without guilt, right? Now we don't feel bad anymore. I had all the intentions of doing it. If only I had a boss who would do it. By the way, there's another name for it. It's called excuse. Okay, sorry, that's not the word. It's called lame excuse, right? Because if you are so thoroughly convinced, you would not tell only if your boss allowed it. Because there are so many things you do at work that you do without the boss's permission. I know what those are, right? Well, you know what those are already. So if we are thoroughly convinced, so when people come to me and say, how do I convince my boss? I tell them, no, your boss is not the one that needs to be convinced. You are the ones that needs to be convinced first. Once you are convinced, you're going to do it, right? So that is the first thing to do. That how do we convince ourselves? By actually doing it. The reason why this is so important is, if you look back in time, by the way, I think our industry is in the year 1820. Literally, it's year 1820. Because in the year 1820, the medical world was very different. The doctors didn't wash their hands, by the way. And the greatest of doctors, by the way, walked around with blood on their coat. And they were proud. You would say, Dr. Jones, he's coming, step away. How do you know he's a great doctor? Look at the blood he has on his coat. And the more blood he had, the better doctor he was. And patients, by the way, in the meantime, the death rate after pregnancy and the death rate after surgery was very high. A lot of people never came back home after surgery or pregnancy, right? Delivering a baby. Now, there was this correlation, right? There are great doctors, and yet the death rate was high. What's going on here? And eventually, of course, a Hungarian found out what was going on. He said, hey, there's germs causing this. And they went to him and said, really? Can you show us the germs somehow? Can we see the germs? And of course, they didn't have techniques to show germs because this was way back in time. He said, no, I cannot show you germs. And so they put him in jail and they beat him to death. He died at the age of 47, by the way. Moral of the story, if you speak against authority, you be ready to die, right? But eventually, of course, James Lister came along and said, maybe this guy really was saying the truth. Maybe there's germ. And he came with this germ theory, founded it more. And he's the one who actually introduced this, hygienic practices to wash your hands, for example. And then to use sterilized equipment when you use equipment in the hospitals. So if I go to the doctor's office and the doctor doesn't wash the hands, doesn't put on a proper gloves, and doesn't follow proper things, the first thing I do is I leave. And the second thing I do on the way out is call authorities, right? And say, this guy is really malpracticing, get him out of here. Because it's going to cause, a poor health. Well, in software development, we are at the pre-hygienic phase right now. We don't believe in washing our hands. We don't believe in using soap. I mean, we can save so much money if we don't use soap. Isn't that true? I mean, look at my wife would be happy because I would shower less. She says I shower for 1 hour every day, even though it feels 10 minutes for me, right? And we can save all this money, right? But of course, then we're going to pay very dearly to the doctors, as we do sometimes. So I think the hygienic qualities are very important. So what can we do about this? I want to write test. But how am I going to write test? There are tons of tools available, by the way. I don't care what tool you use. I really don't care. But if you're interested, you could use one particular tool, and that tool is called Node Unit. Oh, by the way, if you're interested in installing stuff on Node, it is shamefully simple. You simply use a tool called npm. And as soon as you install npm, you have installed almost everything you need. You just do npm install, and it installs it for you. But remember, I mentioned to you already that I'm a lazy guy. In fact, if you look in the dictionary of the word lazy, my picture is next to it. That's how lazy I am. And if you and I are working together, and if something doesn't work, and I complain about it, and if you tell me, oh, Venkat, you got to install it, I will frown upon you and say, what? You want me to install it? I'm not going to do that. I'm going to go get a cup of coffee, and by the time I come back, it better be installed for me. So how do you do that? Well, I use a tool to automate installations. So I come from the world of automation. I've known what people use in Java to automate. They once upon a time used Ant, right? He's laughing. But Ant worked, right? Now they use Gradle, and I'm quietly skipping other tools I don't want to mention here, right? Maven. And then, of course, there are tools that you use on the .NET platform, like what? An Ant or MS Build. And on the Ruby side, I use Rake. In Groovy, I use Gradle. So when I got into JavaScript, the very first thing I did, honestly, is I didn't write JavaScript. I said, heck, I'm not writing JavaScript. I want my Rake. And I said, well, what could be Rake, by the way? So it was no coincidence I found a tool called Jake. And so there is Jake, and you download Jake. So the first two things I downloaded were three things I downloaded was Node.js, NPM, and Jake. So you create a Jake file, and the minute you create a Jake file, in your Jake file you can set up task, just like you create task in your Rake file. And you can say, run this. And then it would do the cleanup for you, whatever it needs to clean up. If you don't have something on your machine, Jake can go install it by running npm. What's the benefit? The benefit, if you and I are working on a project, you installed a certain things on your machine, you check in your code, and I come to my machine, I check out the code, now I sit there and say it doesn't work. What a pathetic situation to be in. It's a waste of time, right? We get paid money to do this work, right? And you don't want to waste your time sitting there and saying, I wasted 20 minutes today because I don't know what to install. We got to be very sensitive to the company money we are spending, right? So what do? I get the code on my machine, and the source control pulls not only your code, it pulls your Jake file for me. Now I simply say Jake, and it wakes up and says, oh, Venkat, you just got new copies of files on your machine, and looks like you don't have this npm stuff installed. Brr, it installs it for me. Within about 2 minutes, my code runs, and every test passes. So automation can save us so much time and money. So if you're working on a project, and if you're wasting time installing stuff, stop doing it. Professionally, it's irresponsible to be wasting money on projects like that, right? Every minute we spend on company's time, we should ask ourselves, if it is our money, would we be spending it, right? And that is something to keep in mind. So use things like Jake and have those installed through the commands, through automated scripts. Now you can do npm install of Node Unit. Great. So how do I use it? So here is my first test. I'm going to call it as calculator test.js. That's the file name I created. And I'm also going to create here a calculator.js. That's my second file I'm creating here, right? So I got two files on my hand. So how am I going to use these two files? Well, let's get to the files first of all. Here's my calculator test. And I'm a big fan of starting simple, starting small, taking small steps. So I'm going to create for myself a test called a canary test. That will tell me that the tools are installed properly, that I can run things. So all that I'm going to do here is simply say exports.testCanary. And the test I'm going to write here is going to be a function. This takes as a parameter, by the way. It takes the test as the parameter. So right there is the test. And now I'm going to simply say test dot. I could simply say OK and say false and make the test fail. And then I'm going to say test.done. And I'll tell you why I'm doing that in a minute. So node unit and calculator test, I'm going to run that. Of course, I could run this through Jake as well. That would be easier if I do. And in this case, all that I did was I ran the test. And it said, you're wrong. True is not equal to false. Of course, it's not equal to false, right? So the test is failing. So that tells us the test tool is running just fine. So what am I going to do now? All that I'm going to do is to make the test to pass. And so I'm going to say this is true. And let's go back and run the test. And notice how it's nicely like a well-fed baby. It gives you a green bar and keeps quiet, right? So that's an example of how you can run the test fairly quickly. So we just wrote a canary test in here. And I'm using Node Unit. Like I said, there are plenty of tools available, right? It's kind of like the soap bars in the store. You pick and choose which soap you want to buy, but please do use soap. And the same thing, by the way, I'm not saying soap as in soap UI. Programmers are really troublesome batch, right? Now they are looking at web services. That's not the soap I'm talking about. That's a bad soap. That gives you disease. I'm talking about the soap in the store at this point. So the point really is that it's important to do unit testing. Doesn't matter what tool you're going to use. Now the same token, the next thing is I'm going to write a test to go run the, let's say a calculator I'm building. How do I do that? Very simple. Exports test add. Let's start with the add method. And this is going to be a function again. And this one says I'm going to use the test. Now we're going to use a slightly different method here. Calculator equals new calculator. Well, where's that coming from? We'll figure out. And then I'm going to say test dot equals. And I'm going to say 6 comma calculator dot add, let's say 4 and 2. So again, I'm doing test first development here. And then I'm going to say done over here to call this. I got to fix a few things before this works. What is this calculator, by the way? Well, I need an object of calculator. Where is that coming from? So I'm going to say calc dot calculator. So in here, we're going to do a require. So require. And I'm going to require the class, the file called calculator.js. And I'm going to store it into the calc variable. So notice in this case, I'm actually going to just call it as calculator. Calculator. Let's actually use the functions directly. So calculator. And now that I have a calculator on my hand, get rid of that. Simply say calculator.add. How simple that is, right? So calculator here refers to what I'm going to require. It brings the comments module here. And then once I bring the calculator into the code, I'm going to simply say call the add method on it and make sure it's working. Well, for this to work, I'm going to go to the calculator. I'm going to say export.add. And this is going to be a function that I'm going to create. And the function that I'm going to create is going to take two operands, op1 and op2. And let's just return 0 for now, just to begin with. So I'm going to go back and run this test. Oh, that failed. Oh, I put export. Let's make a change to it. And go back and run this. And now it tells us 0 is not equal to 6. So that tells us it was able to call the method. And of course, for this to work properly, I'm going to return op1 plus op2 in this case, because that's the implementation of that I want to use. And now we have two tests running, so fairly easy to go through and write this. So we wrote a bunch of tests. Similarly, so what did I use here? I used a OK, which is like a assert true. I used a equals. There is quite a number of methods available. Just like in JUnit and NUnit, you can call these methods on it. So you're just calling these on these objects. That's great. Now we can go a little further with this. This is so far so good. Unfortunately, though, life is not that simple when it comes to JavaScript on the server side, or even on the client side for that matter. The reason is, in the case of JavaScript, we normally do event-driven development, meaning you never call methods and say, go do this and give me the result. You always call methods and ask them to do the work and forward the result to another method or function which can do stuff with it. So why do we do that? The reason we do that is you are in a single-threaded situation most of the time in JavaScript. So if you start doing things that are going to take time, your application will quickly become non-responsive. But it's even worse than that, by the way. It may not even get non-responsive. You can quickly get into a deadlock situation. So, for example, let's say I desperately want a cup of coffee. I could say, could you please get a cup of coffee for me to somebody who's willing to help? And then I go on to talk, and the cup of coffee may be waiting here, but I never go get it to drink because I'm still busy talking, right? So I have to yield at some point to go attend to other things. So one of the things you do normally in JavaScript is you rarely call functions and leave it. Most of the time you call functions and send callbacks to it. And then the callback will then pick up and do stuff for you, which in turn may have other callbacks, and then it may ripple through in the system. Well, that's great so far, but there is one small problem in this case. Let's go back to the code and look at an issue that we will run into very quickly. Let's say for a minute I want to write a test for finding a Fibonacci number. And I could say, for example, in this case, I'm writing a test, and I'm going to say test equals, and we could say 1. And what is the Fibonacci number of in the first position? Well, that's easy. In the position 0 is 1 as well. So we could write code like this. And then, of course, we could say test done and verify that. Well, if I write the code this way, how is fib going to work? We could simply say exports and then give the fib equals function. We could say position, and then this, of course, could simply return a 1, right? In this, to satisfy the test we already wrote, that could be just good enough. We could run the test and see it pass, and life is good, we are happy. But unfortunately, though, there is one small problem in this case. You would not write the fib function like this at all. And the reason is, the fib function is going to take a little time to run. And if you call it this way, your code is going to block and wait for it to run. And that's not a good practice in JavaScript, because your programming at large in JavaScript should be non-blocking calls. And anytime you do a blocking call, you are really entering into a bad programming territory. So how do you really deal with this? The way you may do this is, for example, you may call the function, but you would pass to it a callback. And you're saying, here is a callback, call it when you are done with the solution. So what would you do here? You will simply call the callback and send the result to it. So this may appear a little roundabout, but what you're doing is you're saying, I'll come in here, do my work, and I'll go call the callback. Now obviously this doesn't make sense, because you just call the callback, and the callback is going to go run on the other side, but who is going to process it? You're in the same sequence of operation. So to make this work, what you would do is you would simply go back here and say, first of all, you would say set timeout, and you will do the callback after whatever time it is, and then what are you going to send to him? The result you want to send, you're going to put here. Obviously, you won't put the result as a 1 here. You would do the computation, but we will worry about how to do that in just a few minutes. Let's start with a very simple situation first. But how is this going to work? Now if I go to the test, this is no longer going to take fib like this. It's going to take a 0, but I got to send a callback to him, right? What is this callback? Well, the callback is going to be a function that I want to write here. So this is the callback equals to function. And the function is going to take a result over here, and I'm going to get the result back. Well, how do I verify the result? You may be tempted to do something like this. You may say var, and in this case you may say the result is empty to begin with, and then you may say the result equals result like this, and then you may be tempted to come back here and say that you want to say test as equals. So call the fib method first of all separately right here, and then once you call the fib method, you could say test equals the result, and you may want to check this. Now at first sight, how does this look like? Oh, I'm going to set up the callback first. I'm going to say the result is 0, set up the callback. Then I'm going to come and call the fib method and tell him to go call the callback. Then come to the result, check the result, and do the done. Well, there's one problem. You are in a thread. You come into the line where you're creating the callback. You're in the same thread. You come into the call to the fib method. You're in the same thread. You enter the fib method. And in the fib method, you said, hey, go do this event for me. And then you immediately come out of the method because you're non-blocking. And you come to this line where it says equals 1 is the result. And it says, no, it is not. And your test fails, right? Because the other event you asked for never worked. It's kind of like saying, could you please get me the coffee? Where's my coffee? Patience, Venkat, patience. Things don't work at the internet speed here, right? It doesn't work anywhere for that matter. So I should ask coffee politely, and the person should come and tell me, here's your coffee, would you like to drink it? Then I can respond to it, right? So how do you deal with that? So if you run this test, unfortunately, it is going to fail at this time. That is because it is not going to wait for it. It said 0 is not equal to 1. What do we do? Well, now you know what this done is. The done is a clue that you are giving to node unit to say, I am really done with my test. Of course, in this case, it never got to the done. If you had told him done, he'd be so happy. I'm done with the test. But where is the done should happen? It should be done when the message comes back. So notice what I'm going to do now. I'm going to replace this code just a little bit. I'm going to get rid of these guys. I'm just going to call this method alone here. And I'm going to remove this part here. I've got the callback function. And within the callback function, I'm going to say the test.equals, and I'm expecting a result of 1, test.done. So notice how this is simpler than what I had a minute ago, but it's also much more direct. So I created a callback, but only in the callback I do the assert, and then in the callback I say done. In other words, the test is not done until you call done. So it's going to say, I'm running through the test, I'm not done yet. So it comes to the end of this method, calls the fib, comes out of the test and says, I'm done with the code in the test, but I'm not done with the test. So it waits for the test to finish. And it yields control, and it waits. And the code now picks up the other function you call the callback. The callback runs through and comes into the test through the callback, does the assert and says done, and node unit says, oh, I'm done with the test now. Make sense? So in other words, to deal with asynchrony, you made the test asynchronous as well here. So to do this, basically, you have thrown this back on the loop in this particular case. So now if you go back and run this code now, the test itself, you can see that the test is actually passing. So it's very simple case to write, as you can see, to make this work. Now obviously, you could throw a lot more at this, right? Obviously, in this case, you want the fib to do the real work. So let's go back to this and write another test. We'll say exports and test fib big number. And what is the big number I want to use? Function test again. But this time, I'm going to say callback equals function result. But this better say assert equals. And in this case, I'm going to say whatever the big number is. I don't know what the big number is, 10926. And I'm going to say this is going to be fib, the result that I get back. And then here I'm going to say calculator dot. So basically in this case, the object I have on my hand, dot fib. And I'm going to ask for a 20 and then give him a callback. So this is going to say that the result of this fib value should be that value. I really don't know what that value is. I'm just making it up here to see what that value would be. So how would this work? If I run the code now, obviously the test is going to fail, but it didn't fail for the reason I expected. Let's fix this. You didn't see me write assert equals, did you? Too much habit of writing a JUnit test. All right, so test.equals over here. There we go. So run this, and what does it say? Undone test. It says the test is not done. Now you know that you have to call done over here, right? He's complaining you didn't finish the test. Run this again. It says 10926 is not equal to 1, and that's obvious because I lied here and I gave a value of 1. By the way, you got to be a bit careful. If I do the math here, it is utterly stupid, right? Because you would be doing the math in the same thread, only to put the result on the other thread, and then you come back and say, I'm back. What took you so long to come? I was doing all the work. So now that you took all this time, what's the result? Oh, he is getting it. Right? That's not going to make a big friend for you, right? It's like you took so long and you didn't come back with the result, right? That's not going to be fun. So you want to push that into the other thread where you want to run this. How do you do that? Well, let's get back to this and see how we could do it. So in this case, I'm going to simply say fib at position equals, function will say position. And in this case, of course, I say if position is equal to 1, Then I want to say return the value, the position itself, actually in this case less than 2, return that. Otherwise, what do I want to do? Well, give me return fib at position minus 1 plus the fib of position minus 2, isn't it? So this can give us the value at these two positions. Great. Now, given this value, what do? I certainly don't want to call that here. So what should the result be? The result here should be the result of this computation, but I want to postpone the computation itself. So we will say lazy eval. So I'm going to ask him to call this method lazily. So var lazy eval equals function, and all that I'm going to do here is simply say return actually in this case it's a callback I'm getting, right? So callback, and I'm going to tell the callback, give him the value of fib at position. What is the position given to me? Position itself, right? So this could be, let's call it location to avoid confusion. So this should be location. So let's make sure we got this right. So I wrote a little function, and this function says I'm going to do this recursively. If the position is less than 2, I'll give you the value 1. Otherwise, I'll give you position minus 1 and position minus 2. That's a function I wrote. But then I write a lazy function. In the lazy function, I pass to the callback the result of fib at position at that location. But rather than executing it, I threw the lazy call into the set timeout and said, you go do this for me, please. Am I making sense? Right? So let's go ahead and see if it works now. I go run this test now. Notice test fib still worked. But on the other hand, this guy failed because I was off by 20. Hate those off by 20 errors, right? So basically in this case, I have to go give the right value, and it turns out it was 10946, and I'm going to give that value, and the test is passing. Of course, you don't write tests like that. You actually make sure in math that it's correct, right? Don't ever trust the code you wrote and say, oh, it's got to be good, right? He's laughing already. So do the math and then make sure you're putting the value properly in there, but you can see how the test is working. So like I said, I care a lot about test-driven development, and this is very important. In fact, when I was teaching my son to program, he actually wrote test cases before he wrote any code. So that is extremely important. My goal is that we will have next generation of programmers who grow in this world where they always wash their hands and think that's the way to do things, right? The hygiene should be ingrained practice, and we should have to teach hygiene to people later on in their lives. That's something they should grow with. So this kind of brings us the point to the event-driven programming. How do we use this in the code? Well, we can use that fairly well in the code to do certain stuff in here. So let's go back to the code here to see how that would work. So let's close these. So in the case of JavaScript on the server side, you don't want to do the operations. You want to do it on a separate thread. So here's an idea of code that shouldn't be written. So this is going to be bad idea. So for example, I have a function here. Let's call it as dong function equals. And this takes the times you want to do this. And it basically says over here, for I equals 0, I less than, and let's say times, and I plus plus. And all that it does is it's going to print out, let's say util.print, and it's going to simply print dong, right? So that's all it prints. And this is going to be a require. So var util equals, and let's just say require, and bring in the util API for us to use. So I'm going to call the print statement. Now, if I were to call this, it's going to do this, right? I'm going to call dong and send 5. It is going to go ahead and print it, and you can see that it's printing each one of them. But this call, if I put a sleep here, by the way, so if I go back here and call a sleep, and this is a sleep call, by the way, all of these are npm modules. I just say npm install sleep, npm install util. So if I'm going to say sleep.sleep, and I'm going to ask him to sleep for, let's say, a second between this, just to simulate a little call. Now, if you notice, it is doing that at 1 second interval, but notice how I am blocked on it, right? That is not a good thing at all. Actually, in this case, I said 1,000, which is probably 1,000 seconds, which is even a bigger weight. So in this case, of course, we are starting this, and here I'm going to say done, but you cannot get to the done at all until this whole thing is over. So this is kind of 0. What do you want to do? You're done, right? You don't have anything more to do. else, what do you want to do? I want to then print util.print, and in this case I'm going to say dong, and then I'm going to simply say set timeout. Oops. So in this case I'm going to say set timeout, and what do I want to call? I want to call dong, and I want to call it after a 1 second delay, and I want to give him times -1 as a parameter I can pass to it. So I still call dong here, but if this is not equal to 0, then I do the rest of the operation, right? If it's not 0, print dong, and then set the timeout, so you can repeatedly call, but this time do times -1. So this essentially is going to put you back in the loop and have you run this. So if you run this now, you see that bad idea got printed, and done already printed, but it's still printing dong because we are in a non-blocking mode, right? By the way, this is a very sad news. I came to know this recently. You know the Big Ben clock? This is really troubling to know. Big Ben clock, which of course is the most wonderful clock in London, somebody has a Twitter account for it. And it's a disgrace because there are 400,000 people following it. And at every hour, it says dong. That's it. At 2 o'clock, it says dong dong. At 3 o'clock, it says dong dong dong. And there are 400,000 fools signed up to it. And I hope you don't sign it up. It'll just increase the count if you do, right? And it's just, I was just amazed that people actually Twitter subscribe to an account that keeps saying dong every hour. We really need help, right? We definitely need help. But anyway, I was kind of totally shocked about this, that there's actually a Twitter account which says dong every hour. Anyways, so that is an example of how you would do an event. But of course, computational intensive things you don't want to put on it. How do you read a file, by the way? Well, another module to bring in. Let's look at an example here. So let's say fs equals require, and I'm going to bring in fs. Well, I want to read a file. How do I do this? Well, I'm going to say fs.read file. What file do I want to read? Etc. hosts. So I'm reading the file etc. hosts. And what do I want to do with it? By the way, when you normally see people write JavaScript, they would write this function, and then they would put this other function right there. And of course, that function is going to be a few lines. What do? They would put a curly bracket and write a few more lines of it. It even gets better when your function takes 3 parameters, right? Function on success, function on error, and function on something else. And now what do you have? A function starting, a little parameter, a comma, a big function, a comma, a big function, a comma, big function, a comma. If you find those people, slap them for me, right? There is absolutely no reason to write that, because you completely lost readability of code, and it's very hard to see where it begins and where it ends. So it's a very poor practice. There is absolutely no reason why we cannot write readable code in any language. And people write code like this, and they come back and say, oh, JavaScript is not readable. No, the JavaScript you write is not readable. Tell them that, right? JavaScript is not readable. So you can definitely write it properly. So how do you do this? So I'm going to say over here, a process file, let's say. So this time I say var process file equals, and you define the function right there. It can take an error, it can take a data, you do whatever you want to do with it. So I say if error is equal to undefined, and what do I want to do? If it's undefined, then this is a good data. I want to print the data that you received. Otherwise, I want to say that there was something wrong. So in this case, I would then say here, else output, oops, and then we could print the error message itself, in this case ERR, right? So we could do that. So how is this going to work? Notice what we did. We said read file, gave him a file name, and then we went off and asked him to go read the content at this point. So in this case, of course, I run the node and I run the sample in this case, and it says oops null. So obviously he didn't get the proper value in this case. What's the problem? Well, I tell him to go etc. hosts. That's a file that I have on my machine. A process file. It's going to be the error and data. Let's make sure this is actually coming in properly. Let's just print the data and see what it does first of all. So let's say print the data. So this is a good case. and obviously I made a mistake in writing the code. It printed my file in this particular case, right? So it was fairly quick. However, how quick was it? There's a way to know this. First of all, let's fix this code before we go any further. So I'm going to say in this case, if there was an error, so in this case we'll say error is, if error, let's try this and see what it does. So if it's an error reported and it says oops null still, so obviously in this case, if it is not equal to undefined, or maybe you can use a type of undefined, we'll see. One too many equals there. There we go. So yeah, so it printed the content right there. But what if there was an error? What do we do about it? So in this case, if you notice, we read a file, but what if you want to read multiple files? Look at the beauty of this. You can read multiple files by simply putting another file to read right there. So, of course, in this case, both are the same file. I run it, and notice it printed both of those one after the other. However, if I go back to this code, and I put a little asterisk so we can actually see it, and I make a little mistake here, right? So let's say I said etc. huts instead of extra house, and run this code, what does it do? Now notice in this case, it only brings up the first one, and the second one it says is undefined, which is this guy over here. So the error should come in and report it, and obviously in this case it says it's not giving us the proper value. I got to see why the error is not coming back here. But anyway, the point is that it reports it even first, as you can see, before even it reports the content. Why so? And the reason is because when you are reading these two files, it obviously takes a little bit longer to read the content of the file than to report the file was not found. So obviously that ran fast. But this also shows us something though. Notice how these two were working concurrently. Well, JavaScript is single-threaded, but JavaScript doesn't wait there and twiddle its thumbs. It is performing I/O operation, and it says, I can do those two I/O operations under the covers at the same time. And remember, these are implemented under the covers in the C libraries. So when you're calling fsRead file, it takes care of waiting on the request in a non-blocking fashion. And while that I/O is happening, you started another I/O operation here in the read file. And as a result, both these I/O operations here are happening exactly at the same time. And that is why you are not waiting on one to finish for you to start the next one. So they are working concurrently at this point. So we covered quite a bit of details about how the code works. The more important feature here is the asynchrony. So the answer to that is, anytime you're doing an operation, if it's going to take a little longer, delegate it to a task that is going to run asynchronously, and then go back and yield, and then continue with your operation. How can we use this to create services now? Well, that's not too hard. Let's talk about taking this to a service. I want to talk to a service. It turns out it's fairly simple to talk to a service, actually. So let's look at an example of talking to a service. So here is a service that I'm going to talk to. Let's say I want to just open up my website and take a look at what its content is. How is that going to look like? Let's bring in some code here and take a look at it. It's fairly simple to see. I'm going to use HTTP require on HTTP, and I'm telling him where to go, to my website, to the port 80, to the slash, and you are going to follow essentially this event-driven model everywhere that you are turning around. So I have a process error method. Now notice the first thing I did was write an error, because I want to be very defensive in my coding, right? So what do I do? When there's an error, I say there's an error. Then I say the content, and I have a function called process chunk. In other words, remember this is asynchronous. There is a problem, right? If you're going to take a long time to run things, it's going to take a long time to respond. So here is a way to think about it. Let's say for a minute that he has a question for me. I could start responding to his question. And if I respond to his question, maybe he's got 7 questions. I can start responding to all his 7 questions. In the meantime, he gets really uneasy. As you can see, he's shifting around. He's like, when is Venkat going to be done with this? So instead what I'm going to do is, I'm going to take one question from him and say, great question, and I'm going to go over to him, right? He doesn't know this, right? Because maybe I'm in a terminal, and I say, what's your question? He tells me what his question is. He says, great question. And now I go back and answer him, and I context switch between back and forth, and He took a little longer to get the response. He took a little longer to get the response, but both of them collectively got response relatively fast instead of, starving him and doing this. Now, I always kind of said, is this really true? But actually, I have a proof that this is actually true. I went to a restaurant with 20 people recently. And you know what happens when you go to a restaurant and sit in a table with 20 people? It takes you an hour to get the food. Because they prepare all the food, and then they come and serve food for everybody. Because when you're sitting with 20 people, you don't want your food to arrive and you eat and then you wait for the next, everybody else around, right? That doesn't make sense. But we said, we don't want to spend an hour in the restaurant. So we were this is what happens when programmers go for meals. So we went there and we told them we want 4 separate tables. We couldn't talk to each other, but food was more important than talking at this time. So we took 4 separate tables. Everybody got food in about 15 minutes, by the way. You're like, how is that possible? Well, in the kitchen, they have 4 tables with 5 guys each, not 1 table with 20 people. It just changes the dynamic totally, right? And you kind of sit there and you scratch your head and you're trying to do the math. And you can imagine what I did for the rest of the dinner that night, right? Trying to do the math on it. How would this be possible? That tells you the scalability that Node.js gives you is that it context switches between things. So as a result, you want to divide things into smaller pieces. Now you see why the process chunk is there. Because when you go to the server, it says, I'm going to read this stuff, but I'm going to read some and give it to you and yield. If you have other things to do, you can do it, and I'll come back and read some more, and it really multiplexes between these things. So that's process chunk. The next thing you see here is display result. When it's over, I want to display the result. But how does this work? So I create a function called handle response, where I subscribe to a data event, and I subscribe to an end event. So this is fundamentally the difference you're going to have in programming in Node, is that you do event subscriptions. You don't come and say, can I talk to Venkat? You say, here's my phone number, ask Venkat to call when he's ready. Then here's another phone number, ask him to call if he's going to run away and not be able to meet. So you basically subscribe to these events. And then once you do this, now you go talk to the HTTP object and say, I got a request for you, and here are the options, meaning the site I want to go talk to, and I'm going to subscribe to this event. And once I subscribe, I then say, on error, go process this, and then I say, go run off. And then eventually I terminate the connection and say, I'm done, and I close the connection. So when I use this, by the way, what does it do? So I run this code, node, and then I run the sample in this case. Let me save the file. That would be a nice thing to do. So go back and run the code now. And you can see that it's taking a little longer. It's going off the web. And right there is the content from my website that it pulled up. And you can see that it's the content that was brought back. Of course, if you're really interested in looking at this in a different light, let's do this quickly. Let's remove the display of the result. But instead, I'm going to simply say a got chunk over here. And go back and run this again with the poor spelling of chunk. And notice that it got chunked 3 times this time because it's firing these events as they happen, right? So it doesn't wait to bring it all in one bulk. It's just giving that in pieces to me. We can also create a service, by the way, in a very similar way. And creating a service is not a whole lot different, especially if it's going to be really processing some data and responding back to you. How does that look like? Let's take a look at an example of just doing a service. So notice the amount of code that I'm writing here. Not a whole lot. So I again have HTTP. I subscribe to the URL. And I have a query string. These are all to process various parts. And then I said, I've got a function. This is actually very logical if you look at it, right? I got a function which will take a request and process it and send a response out, right? This is what you do in a servlet API also with a lot of other clutter around it. So once this function is called, what am I going to do? I have a function which is going to write stuff out. And in this function, I'm writing a status on the header. I want to write a content type is text plain in this case. And I'm going to write a message that you give me. Again, I believe in writing modular code, very small pieces that I can put together. So now I say, query string, go ahead and parse from the URL and get the params data. So I'm just processing the query string coming in. And then once I get it, I say, name is, if the params has a name, that's your name. Otherwise, your name is you, right? And then, of course, I print a message, hey, name, have a great day. Very simple service, right? and then I write that message onto the response. So that is all I'm doing. Once I do this, I say I'm starting the server, and I'm listening to port 8084. How would this look like? Well, if I go back and run the code, it starts the service. Again, it's a good idea for me to save this file. So it runs the service, and this time it started the service. Now I can go to the browser, by the way, and I have 8084 as the URL. So localhost, and I'm going to say 8084 without any data. Notice it tells me the time, and it says, you have a nice day. On the other hand, if I go back here and put a question, and I say name equals, and then I say Naresha here, you can see, oops, what did you do? I should have guessed it, right? So name is going to be the value that I want to send, of course, with the slash over here, and it says, Naresha, have a good day, right? Or a great day. So that's an example of how we are processing the value. And again, look at embarrassingly how little code we have to write to get something fairly quick and running. So you can write services like that. What about serving pages, by the way? Well, that's going to take a little bit more effort. If you want to really start writing full-blown web server, then you probably want to look at an Express, which is a library that's available on Node. And Express will give you the MVC and the model view controller. You create directories, put controller, and you put services, and you start writing them over there. But putting HTML pages in there is not a smart idea. Then you would do template rendering engines. For example, there's something called Jade you could use. There are a few other tools you could use as well. You can also create a service which is non-HTTP. I'll quickly show that to you before we are done. So not as a service, how would it look like? Very simple again. This is a chat service I'm going to create. And the chat service, again, is a fairly simple service. Again, you can see here. We, again, go here, but we're getting a net. The concepts are very similar. You got a function which receives a send message, is going to send a message to a client. Very simple method. And I have a handle connection which receives a client, reports to me a client has been connected, registers the client so I can talk to the different clients, and then I'm going to tell him that I'm going to respond to a certain messages. And then, of course, if a client walks out, I'm going to remove the client from my service, right? So once I do this, I register again to a data service, and I register again to an end service. Again, the same pattern is happening here, as you can see. And I want to respond to a message or remove a client. And once I do this, I register a connection to him, and I start a server. So very similar pattern, again about 35 lines of code, even with proper amount of modularizing the code. How would this look like, by the way? Once again, let me save this file and show you how this is going to look like. So in here, I'm going to start the server first of all. The server is running. But on the other hand here, I'm going to go ahead and start two services. But how do I connect to this? Well, it's fairly easy to connect using telnet. So I'm going to say telnet localhost, and what I'm going to connect to here is the port number 8080. So I'm going to say 8080, and that's exactly what I'm going to do on the other side as well with local 8080. So I've got two things connected here. So this guy is connected. I'm printing some stuff over there to get some data about the connection itself, and I'm connecting over here as well. And he says, print a message. I type hello. Notice the message I type here is appearing over there, and you can type a message over there, and that appears over here. But I could quit this and go, and that's perfectly fine. And that guy is lone and sitting over there, which is perfectly fine, and he can deal with it. I can bring up another connection now, and I can type that. You can see that's responding, but the other one is gone. So very simple. If you think about the amount of effort it took, is simply, again, registering these kind of patterns of event and giving functions for him to handle. So that's essentially what you do in connecting to these services and working with it. So in summary, JavaScript has turned to be a very powerful language, not just for the browser-based programming, but certainly for client server side also. You can write the code and test it for both. This gives you the opportunity to write a common piece of code and share it across the client and the server. I would strongly recommend that you don't use JavaScript unless you embrace fairly good test-driven development habits. It's a good thing to do, and that's kind of the reason why I spend more time on it as well, because I think that's very critical. But once you do that, the next thing to get hang of is the event-based system. And rather than calling methods simply, you will normally either call methods and give a call back, or often register by calling methods and giving a call back. And then when the operations are done, you get the call back and process it. And you can develop fairly simple code with it, or you can go all the way to developing web servers with it as well. Even though it is single-threaded, it really switches pretty fast with throughput, mainly because it doesn't take hold of one request and spend the time processing it. Instead, it quickly switches between clients. And the benefit really is, if you're writing a web service which does a lot of file processing, you'll get a very good throughput. But if you're writing a web service where it does a lot of number crunching, Node.js won't give you good throughput, because that number crunching will still have to take time. So your benefit really in using JavaScript as a server is when you have a lot of blocking. And the more blocking you have on I/O, the much better performance you will get by using JavaScript. But if you're going to do a lot of number crunching, on the other hand, you either don't want to use it or push the number crunching to another process. Then you will get the benefit, because then JavaScript won't be blocking on your process, and then it can do the work, and then you can do the callback. So it's a very powerful construct. And I use Node.js quite a bit, by the way, not to write server as much, but to really create JavaScript that I would run on client side, but I always run it on Node.js because I can get a very quick feedback and turn around for testing. Any logic I create, any math I do, which I need on the browser, I run it through unit test on the Node.js, and then I pull it on my browser. That gives me a quick turnaround feedback cycle also. That's all I have. Thank you.